If you notice this problem, we're still going to start it the same way, and that is by grouping the first two terms together and leaving room to add b divided by 2 squared and to subtract b divided by 2 squared. But that part's going to be a little different in this problem. Now, because there's a leading term, that's what's different here. There's going to end up being a vertical stretch or compression, and we know that because there's a leading term. I factor out just the number, not the x value, not the x term. So I factor out -2, then I have x squared. That leaves me with 4x, and I'm still going to add b divided by 2 squared here, and subtract the b divided by 2 value. So 4 divided by 2 is 2, and 2 squared is 4. Then, over here, I'm going to subtract the 4. However, I really added 8, so I have to multiply it by whatever I factored. So, since I factored out a -2, I still subtract 4, but in this case it's 4 times the -2, and that way we keep the whole equation equal. And then I factor this perfect square trinomial, just like I did before, and I have -15 minus -8. So, I have -15 minus -8. This is really going to end up being y equals -2 times x plus 2 squared minus 15 plus 8. So this will be -7. And my vertex is -2 comma -7, because you end up saying -15 plus 8. That's how I got that -7. Now when we graph this, we go to the vertex, and I say -2 -7, and I notice that this is going to come off the graph, so I'm going to change what I'm counting by here, or actually we'll just leave it the same. Okay, and you guys know how to graph this. If I go over 1, now it's a vertical stretch by 2, I'm going to go down 2, and the same thing on the other side. And if I go over 2, normally I go down 4, but in this case I'm going to go down 8, so 1, 2, 3, 4, 5, 6, 7, 8. This isn't the best way to graph it, but just for time, this is what we'll do. And you connect your points. Typically you'd want to change your scale if it went off it like that, but we'll just graph it like that. So when you have a leading term, you know in the end you are going to have a vertical stretch or compression, and you have to make sure that you multiply what you're subtracting here, and if you factored out a negative term, make sure that you add it.